in this chapter, what we're going to look at are functions, what they are, and we're going to focus on linear functions. That's what we're going to focus on in this chapter. In particular, we're going to look at function notation, that y equals f of x. Maybe you saw it before, I don't know. We're also going to consider different ways to represent a function. We're also going to consider different ways to represent a function. And as I just said, the only function in this chapter we're really going to see is a linear function. That's just a function whose graph is a straight line. Excuse me, a non-vertical straight line. Turns out vertical lines are not functions. We'll see why later. And I think later on in the textbook, not this chapter, I think it's chapter 5, we get to see what are called exponential functions. It's a little bit different. But for now, we'll look at functions. All right. Okay. Also, in this chapter, they cover linear regression and they cover, I think, correlation. Anything I skip, you don't have to know. Now, I don't think I have time to cover everything. I will check with other people teaching this, but I plan on skipping linear regression. Worst case is I come back to it. But anything I skip, you don't have to know. Okay. Now, in many situations out there, in the world, there's always going to be relationships between two quantities. Like there's a relationship between height and age. There is. How much exercise and how healthy you are. I mean, how much exercise you do, excuse me, is not the only thing that affects how healthy you are, but there is a relationship. Also, grades, of course, and study habits. Of course, that there is some kind of relationship, your sleep and energy level. Basically, there's relationships between many different quantities out there. I mean, even in economics, there's a relationship between supply and demand. Now, what we like to do in mathematics is we like to focus on certain relationships called functions. And that's the kind of relationships we're going to consider. They're very useful. Okay, so that's what we're going to look at in this chapter. Now, there are quantities that can change values, okay? Like your height, your age, those things are not constant necessarily. So those are variables. Variables vary, right? Changing. And just like we do in algebra, what we like to do is we like to denote variables with letters. And usually we use X and Y. So you're probably used to that already, but X and Y are pretty much going to be variables for us. They're going to represent quantities that are not constant. That's what's going to happen here. Okay, now, excuse me. Now, between different quantities, what can happen is this. Since we have variables, and we have relationships between quantities, we're going to have relationships between variables. One of them will be the independent variable. Usually it's going to be X. The other variable, the dependent one, that's going to be Y usually. The dependent variable is the one that depends on the independent one. Let me say it again. One variable will depend on another variable. The one that depends on the other, that's the dependent variable. And the other variable is the independent one. So, and usually again, X will denote the independent variable usually, and Y will denote the dependent variable. You'll see later on actually that what we're going to deal with the functions that we're going to deal with, you could think of a function almost like a machine, where your input, something goes into the machine, like a computer, right? Something goes into the computer, like when you type on a keyboard. And then the computer machine will give you some kind of output. It might be sound, it might be a picture, something that gets printed, I don't know. X, the independent variable, will be our input, what goes into the function / machine. It's what goes into the function. What comes out of the function is the output, the dependent variable. And what's nice about functions is this. For each independent variable, you only get one output. You only get one output. It's kind of like in a calculator where, how do I say this? If you put a number in and type the square root key, you only get one answer, one output. If you got more than one output, you may wonder, well, which one do I use? Which one is the right one to use, right? That can be confusing. But a function, you don't have to worry about that because functions only have one output for each input. Okay. And I actually rewrote the definition again here, but let me just quickly go through this and I'll start from here next time. But you'll see though that we are actually going to deal with notation. And let me see, this is some notation. We'll get more into this next time, so if this looks confusing, don't panic. But basically, this is what a function is going to be. Functions are denoted by letters like F. For each input, that's what X represents, you get an output. Something goes into the function, something else. Something will come out of the function. And again, what's nice about functions is for each input, you're only getting one output. So you don't have to worry, well, which output do I use? The function gave me back more than one. You only have one to worry about. So I think it'd be good to stop here because this is where I left off with the other class. And was that sharing? Was everyone able to see that?
Yeah.
Okay, good. I got scared for a second.